GRACEFUL became a part of my life and my work in a very natural way. At a given point in my career, I share an office with very good colleagues and friend of mine, Isabel Panay. I am interested in magnetic field variations. She's interested in gravity field variations. And in our office, we had maps showing the magnetic field and the gravity field hang on the wall. And one day I was thinking, but maybe we are here also to share something about these two fields.
I went to a congress and I have seen Mioara Mandea and Anny Cazenave, and then discussing, we understood that this would be really a very good idea to approach the core from different disciplines and try to get an ERC synergy. And that is what we did.
Being part of the GRACEFUL project really changed my life because it allowed me to look at different topics in science. The Earth system is not just a collection of different compartments, but they all interact together on different time scale, on different spatial scale, etc. So I think it's something that this project allowed us.
In the GRACEFUL project, we have been interested in understanding and probing the Earth's deep interior.
When you are trying to understand what is going on inside the Earth, of course you have the magnetism which reflects what is going on inside the liquid core. A motion inside the liquid core is generating the magnetic field. And there is also the Earth's rotation, and you would wonder, but why does the Earth's rotation represent something about the liquid core? Well, in fact, you can do this experiment. You take a raw egg and a cooked egg and you make them turning. And look at them. You will see that they are rotating differently. With a little bit of habit, you can tell this one is cooked, this one is not cooked. It's exactly the same for the planets and the Earth in particular. By looking at the rotation of the Earth, you have information about what is going on inside the Earth. The only way we can have information about what is going on inside that part is to look at indirect effect. And we have as indirect effect the generated magnetic field, the generated mass anomaly in the gravity field, and the variations in the Earth's rotation induced by the liquid core. At the surface of the Earth, we have telescopes. These telescopes, they are observing quasars. Quasars, well, these are objects that are far away in the sky. So far that they don't have any motion. They are like spots in the sky. So we observe with this telescope on Earth, we observe these quasars. And by observing all the time, you will see in the observation how the Earth moves beneath these fixed spots in the sky. And that's the way we get the Earth's rotation in space.
To understand the magnetic field variations, we use measurements provided, for example, by magnetic observatories. You have to know that magnetic observatories are distributed not uniformly at the Earth's surface. There is a very clear dichotomy between northern and southern hemisphere, but also between continents and oceans. So satellites carrying magnetometers give us a possibility to have a global view of the magnetic field, considering this kind of measurements. On the other side, satellites as GRACE or GRACEFUL bring us information about the gravity field. The gravity field, of course, is produced by mass changes in oceans, atmosphere, but also deep in the Earth. In the frame of GRACEFUL, we just take into account these different measurements. Of course, Each measurement could bring a story about our planet. But when integrating everything, more measurements, we have a new story, we have a richer story, and we have a more complete view of our planet. This helps us to understand a little bit better how planet Earth works, but also this brought us a lot of new questions.
Our objective in this project, ERC project, at the beginning, was to remove the effect of the surface fluid envelopes in the gravity field observation to try to detect some signal from the deep interior. And doing this, we discovered something that we did not expect, that is that there is a 6-year cycle in the climate. It was known already, in particular, this was the expertise of Mioara and Véronique. It was known already that there is a 6-year cycle in the magnetic field, and there is also a 6-year cycle in the rotation of the Earth. We found this 6-year cycle in many climate parameters, in the rate of sea level rise, in sea level rise itself, in the global mean surface Earth temperature, in the ocean heat content. The ocean is the main reservoir of heat of the climate system, and it is, of course, becoming warmer and warmer because of anthropogenic climate change. And we found that there is also a 6-year cycle in ocean heat content. We found this 6-year cycle in land hydrology, looking at, for example, water level variation of rivers, of lakes, and in water storage, total water storage in the soil, in large river basins. There is a 6-year cycle. And finally, we found this 6-year cycle in the winds in the atmosphere. So in the circulation, global circulation of the atmosphere. So definitely there is a 6-year cycle in climate. This was a discovery because nobody knew before that. And now the big challenge, and we don't have the response, is why is there a 6-year cycle in the whole Earth system from the deep Earth interior to the upper atmosphere.
By the end of the project, we still have lots of questions, maybe more than we had at the beginning, which is normal in the research field. So what will be next? Just to try to continue to work together via different projects, because we were so happy during the project, and I'm sure we'll still have the possibility to meet 3 of us, the leader of the project, so with Véronique Dehant and Anny Cazenave, and to continue to ask questions and maybe to find a few answers.
Being 3 PIs, 3 coordinators working on the same project was really an amazing experience. It was really fantastic to work all together.
To be a woman and to lead a project is very important. At the same time, it's an honor, but also a responsibility. It's an honor because you can show that at an international scale it's possible to bring together people and to develop new ideas. But it's a huge responsibility because we are not alone, we are with a team. So we are responsible about our students, the early career scientists. We have to be here and somehow to open the door for them.
There is still not enough women in some areas or some fields of science. There are many women doing biological science, but in engineering, mathematics, or fundamental physics, or chemistry, or even earth science, there are not enough women. The situation is improving. I had the opportunity to look at the number of women at the beginning of the career and at the end of their career, let's say 20 years ago, 30 years ago, and today. So the situation is improving, but there is still only about 30% of women in these different fields.
If my role in GRACEFUL project can inspire younger women, really I'm very happy, because I'm sure it's a way somehow to open the door for them and just to tell them, trust you, you are wonderful.